and gentlemen, audience on Twitch, hello! Welcome back to the InnoVEX Forum. I'm your host, Sophia Cho. 我是周明景. In case some of you just joined us, InnoVEX is the word innovation in COMPUTEX. This is a brand new startup exhibit at the COMPUTEX that creates a platform for startups to have the chance to showcase their product and also to interact with a large number of investors, buyers, and also potential manufacturing partners. During the InnoVEX, there are more than 100 speakers from the world joining us and to share with us their precious insight. This afternoon, we focus on unmanned technology. This is a highly anticipated topic. And I think only just 1-2 decades ago, unmanned technology was still just something we fantasize about. It was just something that happens in sci-fi movie. But now, it not only has come true, it can change our life. So in this session, our speakers will talk about where the unmanned technology is heading and how. Now let me introduce our moderator. Our moderator is the founder and GM of RUG computer brand Perfectron and 7-Star Lake Consultancy. He's also the originator of Unmanned Technology Platform Association. So now, ladies and gentlemen, please welcome our moderator, Mr. Martin Ting. Now let's welcome our panelist, Senior Sales and Marketing Manager of Velodyne Lidar, Mr. John Eggert. Welcome, sir. Our next panelist is the Vice President of StackRack. Please welcome Mr. Benjamin Wang. Now I'd like to invite the Business Development Manager of Robosoft, Mr. Joe Boulay. Last but not least, CEO and co-founder of Milrem, Chairman of the Board of the Defense Industry Association, Mr. Kuldar Vaarsi. Martin, here's your time.
Okay, thank you for the host and thank you for all the audience participate in this section. This section we're talking about the unmanned technology. Human has been dreaming smart life for centuries. Unmanned technology is one of main drive. However, in these days, in these years, we haven't seen so many successful applications like a Google car or Amazon's UAV, they easily can shape the future of our life. And today, I think I would like to draw up this technology and what is the future where this UAV can change our life. And what is the future about those things will change our life from the commercial daily life to factory automation and also to the military, the working in the field. So today, I would like to introduce some of our speakers. First, I'm starting the Robosoft, the leading the outdoor and the indoor autonomous vehicle makers, the Joy. And he from France, he will bring the newest vehicles and also his technology to us. And secondly, I will introduce the Benjamin Wang from the Ruggedized and the computer. If we mention about the Lidar, is the eye of the vehicles. And obviously, the computer is a brain to control the vehicles. So Benjamin Wang was, from his point of view, to share about his technology and his successful case. And of course, the most important things, we'll talk about the LiDAR. What is the position of LiDAR technology in the market? And in the past, everyone will think about only the Google. You have Google car as a LiDAR. But however, the Velodyne is original company, original technology inventor to design and to produce the first LiDAR in the world. So the John will also introduce about the Velodyne, this technology. And in the last, we have the Mr. Kuldar. He from Estonia. He will mention about his unmanned, the tank, how his unmanned vehicles can change the future about the war. So today, it's all of the speakers. And wait a minute. Let's start. Okay, so before we go to the main topics, and you will see the real unmanned vehicles on the stage. So please have your mobile phone, have your camera, take as more the shoot as you want. Thank you. So today, we will focus on the older technologies. I think what I mentioned in the beginnings, the Lidar, what is the main technology to create, to build unmanned vehicles? Is 3D mappings, or the multi-sensor detection, or is the SLAM algorithm, or the other solutions? And of course, the Lidar is the most important things in all of the unmanned technologies. So we have the John to share his point of view, what is Lidar technology, and how Lidar technology can be used in all the different kind of from the air, in the ground, or under the sea. So let's have John. Okay.
Thank you very much, Martin.
Yes.
When I started at Velodyne, it was only about a year ago. Most of the people were telling me that we would see unmanned vehicles on city streets in about the year 2030. At that time, the market was broken into two groups of people. The major OEMs who were doing almost a evolutionary change, little by little, through ADAS. And then there were a few crazy companies, notably Google, who is going to do a revolutionary change. That was only about 12, 13 months ago. I can tell you today, things have changed dramatically since then. Now we're looking at companies around the world. Practically every major OEM is now making the jump to the revolutionary change. And one of the key technologies they're using to do that will be 3D Lidar, real-time Lidar, which Velodyne is the world leader in. Why do you need Lidar? In the past, with the incremental change, ADAS, people were mostly using cameras and radar systems, and also two-dimensional Lidar for their unmanned vehicles or for their ADAS systems. But if you want to go to full level 4 autonomous driving, our feeling is that a 3D Lidar is necessary. So what 3D Lidar allows you to do is do localization. The Lidar will give you XYZ data, spatial resolution, and will also give you reflectivity data. And through that, you can get centimeter accuracy of localization, which is figuring out where you are in a map that has been previously made. Another reason why 3D Lidar, can you go back, please? Another reason why 3D Lidar is necessary is because it allows you to do very accurate object classification. We give enough data to do that. With the other technologies, you end up having a lot of false positives, a lot of false negatives. And finally, the advantage of 3D Lidar is it gives you a real-time response with a very long range. Our sensors go out 200 meters. So it helps you with special use cases like high closing velocity objects and new construction and things that change in the environment always. I'm going to show you next a quick video of Ford Motor Company, what they do in Michigan. This is an example of exactly how people are using Lidar for self-driving, level 3, level 4, and level 5 driving. Go ahead. This is an overhead video of the University of Michigan's test track. It's called M-City in Ann Arbor, Michigan. Now what Ford does, this is Ford's case, and it's also what Google does and other companies doing full level 4 driving, is they do a prior map. Everything you see here is 100% Lidar data. And they generate a prior map of the entire environment in 3D, high resolution. And surprisingly, you can see with Lidar, lines on the road. In fact, you can even see very subtle changes in the asphalt. Now what you'll see is they've got the prior map, and the purple lines are now the live Lidar feed. So what a company like Ford or Google or the self-driving company does is they take that live Lidar data and they match it to the prior map on the 2D surface of the road. And through that, I mentioned localization. They can find out where they are within that map within centimeters, which is absolutely critical for self-driving in an urban environment. And you can see as the vehicle drives, not only does it help you place yourself in the map very accurately, and I should point out that it doesn't matter what the lighting conditions are. This could be nighttime, this could be daytime, the sunlight can be into the sensor, it makes no difference. But you can also see objects come out with the LiDAR with three-dimensional spatial resolution. So you can see the person crossing the street here, that's a live LiDAR feed. So it makes your computation of what that object is very simple when you have 3D volumetric information about that item. As you can see, we're keeping very close to the lines, very close localization. You see the bicyclists go by. I think Google has a very famous use case where a woman is chasing ducks in a wheelchair. And yes, LiDAR can help you see that and help your algorithms understand exactly what you're looking at. And again, this is done by Ford. This is live data with 4 32-line sensors around the vehicle. They aren't using camera and they aren't using radar to do all of this driving. And overall, you can see the overall view of the map here. Again, this is a 3D map, similar to what companies like what Joel will talk about are doing. Google is doing something like this. When they cannot see the 2D line matching, they'll go to the 3D image like this, and they can match up. So sometimes you hear people with cameras saying if you need the lines to be able to drive. Well, with LiDAR, you don't need the lines necessarily. If you have a 3D image, you can match your 3D map to what the 3D LiDAR is seeing in real time.
Okay, thanks for the jump from the Velodyne's point of view, and also he's a very nice, the real case. So now I think everyone already seen the real LiDAR applications. And in the beginning, you already see the small autonomous vehicles. I believe most of you want to know how these vehicles can run from the back end of a stage to the center. So now we have the joy to talk about the technology about the 3D LiDAR in his vehicles.
Thank you, Martin. First of all, the first question, how does a robot become autonomous vehicle? This is the main question. It has to rely on 2 main points. First, its capability of analyzing the environment. Mainly it's based on LiDAR, either 2D or 3D LiDAR, depending on the technology we can embed on the robot. Then it has to rely on a huge capability of computation to run high-end algorithm to match this data to an original map. So, for mapping environment, today we have 2 possible technology, either 2D or 3D. Velodyne products are mainly oriented 3D LiDARs and technology for indoor robots. Due to some restriction of calculation, energy, cost, we have to stick today with 2D technology. Next, please. Okay. You can see here what this robot on stage can catch from its environment just with 2D sensor. So it's black and white, just in one area. So it's quite limited perception of the environment, and the challenge is, are we able to navigate today in an autonomous mode indoor with this sensor? The answer is yes, but not with a single robot, with a single vehicle. It must be associated to a fleet management system and to onboard algorithm. Next, please. So, based on the first mapping of its environment, then the original map must be reworked, and the final target for the robot to be achieved, like one mission to bring some goods or some people from one point to the other at a given time of the day. Everything can be done under simulation through a fleet management system with high outputs capability of computation. And then after some iteration, we are able to set up a proper way, a virtual path that the robot will follow to deal with its daily mission. Then, what can be the future in this technology? It's working today. We will see later on during this speech some use cases. But how 3D technology can improve the situation and the capability of the robots. The main improvements will be on obstacle detection. Because today, if you have just a perception of 2D, it's quite limited for obstacle avoidance. So we have to combine this technology with other sensors, like ultrasonic sensors or visual camera. But in coming future, when this 3D technology, which is more dedicated for outdoor vehicles, will become available and affordable for the indoor products, it will highly benefit our current solution. That's why I can say for now. I think we will
okay.
carry on the
yes, thanks for Joy. Yeah, thanks how from his ground vehicles point of view, how to leverage the Lidar to the navigation and algorithm. And I think the unmanned systems can be used in various situations, and they will be used in the more and the more complex task. And as I mentioned in the beginning, the unmanned technology will totally reshape the future of the life. So can the future bring the fully unmanned units to battlefield? And what are the main constraints? And the coming sections, I would like to have the Milrem, the CEO, Mr. Kuldar, to share his military vehicle and the task in transportation solutions.
Thank you, Martin. I'll try to elaborate how the unmanned technology can change or will change the military applications and the future battlefields. Because the most precious asset what countries send to the war are the human lives. And unfortunately, any war involves a risk to the soldiers' lives. But can it change in the future? And will future bring just bigger weapons, heavier vehicles, and more armor to the battlefield? I think that for some coming years it will be so, but we definitely can see the new era emerging, which brings new technology which not only assists humans on the battlefield, but which also can replace humans on battlefield. And to start from the beginning, we have to understand that the beauty, but as well the difficulty of forward-looking innovation lies in the need to understand the mindset of the next generations. To bring one example, I was 13 years old when I first used my computer. It was IBM 386. But my 1.5 years old daughter has already mastered to use the basics of the iPad. So it is pretty obvious that her generation has different outlook on a world than we do, starting from different motor skills using the touchscreen and ending up with different value system. So it's pretty difficult to try to predict what next generation will exactly evaluate or set as a normality in future, but it's not totally impossible. So as it might be a bit hard to comprehend now, but I would dare to forecast that we are going to see increasing number of smart autonomous land systems in increasingly complex military operations in quite near future. And this is not just another gadget in the hand of the soldiers and infantry, but this will be totally new capability which can change the face of a war. In the medium term, I'd say that we see that unmanned system will take the place of either very hazardous situations or just unpleasant situations from humans. But in the long term, 20 plus years, we definitely will see, so to say, unmanned infantry units performing quite complex tactical tasks. However, for that future, we need to mature in 3 areas actually: in technology, in doctrine, and in ethics. So, to illustrate what I'm talking, let's take a look at the screen. Here we have 2 fire teams, and it's pretty obvious to imagine that transportation devices can support these fire teams during the battlefield, on the battlefield. And there are quite many programs all around the world already going on. For example, in US, the SMAD program. The second quite obvious application will be surveillance or the security drones. But to move to more complex scenarios, we need as well the weaponized UGVs on a battlefield, which can increase the firepower of the unit and as well already replace some humans in different tasks. And these are not just theoretical things. This kind of technology is already, it's existing and it has been tested by the military, and it will be deployed around the world as well. So you can see the transportation device, the weaponized solution, but as well the base platform and later on the sensor package. But can we go even further? Can we actually replace humans on the level of squad or on the level of fire team at least? I dare to say that we have 2 problems to tackle. One is tactical and another one is ethical. And from tactical point of view, we need something similar to the human in the sense of flexibility, which can be used in very different situations, in very different environments. From the technological means, I believe it's doable. If not today, then sooner than we expect. But the ethical question remains, do we really want it? And are we ready to leave robots to decide whom to shoot or when to pull the trigger? I'd say that I would feel much safer if humans still stands behind the final decision when to pull the trigger. But maybe it's just my inability to understand the mindset of next generation talking in me. Thank you. That's all for first topic from me.
Thanks, Kuldar, for bringing us fantastic the application about how the unmanned military vehicles will be deployed in the future. The initial goal of unmanned ground vehicle systems was to equip off-road vehicle with the computer control unmanned operation systems. And the complex technology were including the navigation, detection capability, and also allows the planning. In such a sophisticated application environment and hierarchical conditions, rugged and high-performance computing device played a critical role. And today we have the StackRack, the worldwide leading the rugged computer maker, and they already provide their solutions with the existing our partners. So Benjamin Wang, so what is the design concept and architecture about the StackRack computer can help to running the very smoothly and nice 3D Lidar mapping, navigation, and all of the critical tasks?
Okay, thank you, Martin. So, and after we see that we have the Velodyne Lidar technology, Robosoft, and Milrem, and we know that we are in the COMPUTEX. Okay, so what is the technology? What is the subsystems? And what is the features in the robot in the unmanned vehicle? So, okay. So, the UGV system, subsystem include, okay, first you need a locomotion system. And you will need an energy system. And you will need a positioning system and a sensor system. And you will also need a navigation system and the motion control system. So it is not only, if you look at the drone, maybe, okay, there are many famous drone in the market that you can buy from the retail store. But actually, when you want to run the unmanned vehicle, just on the ground, on the street, in the hospital, or even in the battle, what is inside the system? Okay. So I made a broad diagram of the system, what is included. For the low end, maybe now the very cheap the ARM-based can make it. But for the high end, if it's just think about it, if a bus running on the street, can an ARM-based computer can control the system? I don't think so. So if we look into the unmanned vehicle computing system, okay, if you the first you can see the red color. You will need two computers. The first, you need an image processing computer. The second, you will need the driving computer and build up the real-time OS. We call it RTOS. So what does the image processing computer include? Okay, you need to connect to the cameras, and you need to, the cameras will build up the, as you see, the robots will build up the observation. You need the road to take the picture of the road and do the video slam, and you need a camera on the collar to avoid any contact to hit the people. Okay, you also need the laser scanner, just as the John showed on the video. When it is running, not in your control, how can the unmanned vehicle to identify, okay, here comes a bird, here comes a cat, or somebody running a bicycle, or any other subject. Okay, then the image processing computer, you will need a video link to connect it. And if you look at the right side, the driving computer, okay, it will has the interface of the C2 link we call command and control. And in the right side, the driving computer real-time OS, what it operates. So you can see that for the control system, it will need the accelerator, you need the breaker system, or the gear lever, steering wheel, and the other device. So you also need the odometry and the sensors and the inertial positioning, and you need to connect to the GPS. So some situation maybe just as the Kuldar just show you, once you're in a battle, maybe there's a gun on site. So you also need to detect, and you will need a specific payload to measure how many hours, how long the distance the car still can run. So, and when you look on the bottom side, when you have the video link and you have the C2 link, sometimes in some situation and some application, you will also need a remote control. Just image now as I read from the news, is even the accurate rate of the unmanned vehicle just running on the street. Once 99.999%, there is still some possibility maybe they were hit by another car, the system shut down. That's another topic we can think about in the future, how once the unmanned vehicle running on the street, how the people, when you drive the car, how you see it. Just as a few days ago, and you can read from the news, somebody ride a Tesla car and the driver just sleep, and the car just keep moving. But the people still worry about will it hit the people? So what's the video link and the C2 link to where? So sometimes for the application, you still need a remote control, what it includes inside. The video link, and you can remote, just as you play the drone, you have the iPad, you can have the iPhone, and you can remote control your drone. And you can release the command, and you can have the remote control the system just running outside. So it can connect to the remote computer. Operation is Windows, and you will connect to the steering wheel or the joystick. So, and just think about it once there is an operation system on the street, there is a shuttle bus. And in my experience, normally you will still need a terminal to have the remote control to avoid any accident. So that's what's inside the unmanned vehicle, what is the computing could be inside. Okay.
Thank you for Benjamin shared his valuable point of view about how to use the rocket, the computer, to running the AGVs. In section 2, I would like to share about the connections between Industrial 4.0 and the unmanned technology. Many of my friends, no matter from private sectors, it means my suppliers, my customers, or from the public sectors, I mean the government side, they keep asking me the questions. What is the main element? What is the key, the issues can make the Taiwan catch the Industrial 4.0? For me, I think the robot is the soul of the Industrial 4.0. And the unmanned technology is also one of the core technology to make the robot become a real applications. So in these sections, we would like to talk about and share about is any link between the Industrial 4.0 to the unmanned technology. And I would like to have the Milrem, from his point of view, how the different kind of the unmanned vehicles can be do the integrations, how the modularizations can push the Industrial 4.0 to make all the environment more successful. So would you like to give us your point of view?
Thank you, Martin. Trying to predict or to forecast what is going to happen on the UGV market, we should at first take a look at the unmanned aerial vehicle market and its development. Today, pretty much in every military operation, the unmanned aerial vehicles are in pretty central position. But the modern UAVs were we can say that firstly used by US Army during the Persian Gulf War at 1991. And it didn't, there was not very quick growth straight after that. But if you take a look at the UAV market investments from 1991 to 2016, then we can see that the growth is not even just linear, the growth is exponential. And I dare to forecast that same kind of growth is expecting on the UGV market, on the ground vehicle market as well. And the question is not if, the question is when. But coming closer to the answer to question to Martin, I have had many chances to explain the advantages of smart unmanned ground systems over using the human troops. And very often the generals behind the table are saying that they already have the best available means. They have the soldiers who can do everything. And many of them even think that it will remain so. To very large extent, I don't agree with that. But there is one certain point what we have to have in mind, that human still is the most universal soldier. He can do very different tasks. And I would dare to say that universality is exactly something we need to keep in mind when we are developing the robotics as well. Because single task solutions are too complicated, they are not flexible enough to be used in different scenarios, and they are complicated to use as well. But once again, to illustrate, I can show you one concept how ground vehicle can be made universal or modular, adding payloads on the plug-and-play principle. So having the transportation solution, which can be replaced with explosive ordnance detection, and as well replaced with, for example, advanced weapon systems. But it's, I'd say, a matter of imagination what different kind of applications can be used there. But the another field what we have to keep in mind in the development of robotics is the swarming, or the communication between the robotics on the battlefield. And let's say that from the AI or artificial intelligence point of view, we are very far away from self-aware AI which can act and think like a human. And I would even dare to say that do we really need it, or do we really want it? On the battlefield, we need AI to be emotionless, objective, rational, and to be able to calculate the probability. And of course, in addition to that, avoid collision with trees and rocks. But if we take a look at the technology available today, then I say that we have pretty much everything available to put the smart unmanned systems on the battlefield. On the screen, you can see the raid operation, where different UGVs and UAVs are integrated together in order to give a better situational awareness, to show more information about the target, to send this information over for the precision targeting, and even to analyze and predict the enemy movements on the target. And altogether creating the supremacy on the battlefield. From the sensor's point of view, the technology can see and hear far beyond what human natural senses can. Today, I'd say that the only constraint yet is the ability to combine and draw the conclusion out of this data. But nevertheless, having in mind the deep learning and sensor fusion and other similar technologies, I believe that this will not be the case for too long. And therefore, I'd say that in distant future, this kind of unmanned systems will be much more reliable and much more error-prone solutions on the battlefield than a human. And, well, it's just a matter of imagination to understand how efficient this kind of solution can be if it's equipped with high-end sensors, data swarming, and smart data communication. So, to conclude my short presentation, I would say that the technology itself is not the limiting factor. The limiting factor is our ability and willingness to use this technology. And are we really ready to minimize human participation on the warfare? And do we really understand the consequences? But I'd say that it's not for me to say it's good or bad. And nevertheless, the history has proven, or history has shown, that this kind of debate tends to be irrelevant because more efficient solution wins anyway. And as today's conference's topic is technology, then I dare to say that from technological point of view, everything is possible. And if not today, then sooner than we expect, because technology tends to develop exponentially. And of course, next generations will define next normality. Thank you very much.
Okay, thank you for Milrem, Mr. Kuldar, bring his point of view. And actually, he got more than this, just 3 slides. And if all of the participants, you want to get more information and more content from his speech, actually in tomorrow, in the PM 2 o'clock to 5 o'clock, we have another forum. I do a small advertisement. And you can enjoy it and have a personal, more mutual talk with him. And the location will be in the Humble House. Okay, so from his sharing, we understand the communication between the different kind of unmanned systems, the importance is. And also we understand the true value or the foundation about Industrial 4.0 is how to link, how to do the real-time communication between the different objects. The different object, the different devices, it means the door or is it the cloud or everything. So in this week, we have a very big talk to some of the users in Taiwan with the Joy. We talk about how to make a factory Industrial 4.0 with the robots, autonomous vehicles. How to make the hospital become truly Industrial 4.0. Take it for case, for example. When we go to see the hospital, we see the doctor. Then we will get the prescriptions, and then from the pharmaceutical center, and deliver the pills to the nursing center, and then deliver the pills to each department. Can we make this all the process unmanned? Can we make it happen, controlled by one robot and through by one software? So we would like to have the joy to share that this week we have been talking to some very large-size hospital about this program.
Thank you, Martin. I would like to share with you one use case, which is today's reality. First, I will introduce our products, which are contributing to this unmanned and autonomous vehicle services in hospital, and then share a specific use case. Finally, we will talk a little bit about what is the future improvement of the solution. Next, please. So here are our autonomous vehicle for logistics. Formerly, those autonomous vehicles were called AGV, automated guided vehicles, but those automated guided vehicles are in place in many hospitals in France since 20 or 30 years. Their main weakness is that they need some or many infrastructure modification. Either you need to have magnetic plots or visual artifact or line on the ground to enable the robot to follow one virtual path and to complete a mission. Today, all our autonomous vehicles are based on Lidar technology and need no more infrastructure modification. So they can fit to any existing building or to any new building. So we have 3 kind of products, from the really lightweight transportation, which is done by our NG product, to the heavy load transportation through Carry and Stacy. I will share with you one example that is running since 2 years in a French hospital, in a medium hospital, working 24 hours a day, 7 days a week. Next, please. So this is a Saumur hospital. It's a medium-sized hospital, consisting in around 300 beds, and we currently have 4 carries robots running daily in this hospital and dealing with the 4 main floors, which are laundry, meals, pharmaceutical, and trash. Depending on the need of the operation, there are some missions that are daily scheduled for all of these flows, and on top of that, there is also the on-demand capability to deal with urgent flow. After 2 years of operation, we have an average of 150 missions per day completed successfully. Next, please. So here is a short overview, 3D overview of the hospital, and a short video explaining how the fleet management system handles all the fleet of the autonomous vehicle, as well as all the communication through with the infrastructure equipment like the lift. So you can see that with embedded cameras on the robots, operator from the control room can have a direct access and view of what is happening, even if it's just nice to have feature because vehicles are completely autonomous. But in case of problem, as the distance can be quite long, operator in control room can assess and evaluate what is the problem and take the good action before operation. Here you can see, for example, one insertion of a carry robot in a lift. Door closing, you can follow everything. The lift on the right side, the yellow lift is going up. Then the robot will go out the lift and unload the cart which is inside. You have another carry in front of him waiting for the clearance, the blue one, to go and use the lift. So the robot itself, or a fleet of robots or autonomous vehicle, cannot complete a mission without a really complex fleet management system who is able to plan and to replan on demand the mission in case of something goes wrong, either on a lift or a change of mission on the flight. So this kind of technology is today's reality with really high-end algorithm and technology, with 2D Lidar technology. You can stop it, please. So what will be the future of this technology? Two main things. We started this discussion by talking about 3D Lidar. For sure, it will improve the indoor navigation, but also the capability of high output calculation with embedded computers, really reliable for all embedded software, but also for the supervision and the mission system. That's why we strongly believe that our partnership with StackRack in Asia and in Taiwan will help you and Taiwan bring the Industry 4.0. Thank you.
Thanks for Joy to share about the fantastic, the real software, the demo. I think from the videos you already seen, the very successful robots, autonomous robots, is working inside the hospital to bring the meals or the laundry or the medical waste from the point A to point B, and they can automatically open the door and capture the video and recording everything, and all feedback of the information to the supervisor, and also to help the whole hospital to realize what we call the Industrial 4.0. And behind those technologies, and after you hearing so many developers from the Milrem, from the Robosoft, you already see how to integrate such a so complicated technology and to make these vehicles running. It might have the very, very special computer devices. And Benjamin Wang would like to, from his career, to share his design, the concept idea from their successful case, no matter from the indoor vehicles like a Robosoft, outdoor vehicles like a Milrem, or coming from the tier 1 customers from the Airbus, Thales, Lockheed Martin. How they work with the StackRack, while they use their computer, and what computer can work in those complex systems.
Okay, thank you, Martin. So, okay. So first of all, and I would like to talk about what is the ruggedized guideline. And I think around the world, everybody loves the American weapons. Okay, and when we're looking about the standard of the the lowest shipment ground vehicle, what does we do and the task for our system? Okay, we would follow the two standard and follow the MIL standard A10G. And the first is the test method is the 514.6 for the vibration, and the test method, another one is for the shock, and it's the 516.6. So based on those vibration, I would like to define that we can have the full level of those computers. First, we will have the A, B, C, D for label. First is very generous vibration. We call it the A grade. And for B, we call it the roots cargo. You can consider just when you're riding a bicycle or you ride your family car on the street, and just very normal bump up that we call it the B standard. And for C, we call it the large for the transport, like the train or the big vehicle. And for the D, I will call it, you can consider about the helicopter. And when the engine is on, it's very noisy and the vibration is heavy. Or about the aircraft, when it's the takeoff or when it's the landing, so the vibration is heavy. So when you look at some numbers, you can, bicycle, we call it 4.4 G, and for the car is 2.4, and if you're looking into the helicopter, sometimes it's more than 6. So based on the different situation of the vehicle and the transportation way, we will design the different structure of our computers. Okay, next. This is the case study. This in France, we call it SAGEM, and we have the computer design for the RHIB. You know, for the RHIB on the sea, there's wind and the wave is very big and heavy. So if you're looking at the right side, you can see, the steering wheel, the monitor, and sorry.
Sorry about that.
Okay, sorry about that. So I think I still have 3 minutes, so everybody can take rest. Okay. Sorry, I already made attention. Okay, so what's the computer inside the RHIB, the boat? So of course, there is very ruggedized. In this situation, in the picture, you see this IP67. Okay, next. So what is connected? And when you look at in the standard PC, so your desktop or your notebook, you can see, we have the RS-232 and you have the USB VGA. I will not talk too much about the detail because it's too confidential, but you can see the image. The key important is that you need to listen to your customer's requirement, what they need, and what's the situation, environment they need, and the interface. So next. So this is another case. We work with our customer. The first we call it Easy Mile. It's the autonomous shuttle bus and the Navia. And if you look at last month and 2 months ago, in Taiwan TV news, there's the CTV and the TVBS ever report about the Navia unmanned vehicle in Switzerland and for the shuttle bus. And what's it inside? So what's the car when you want to open? So next. Okay, you just take off the clothes. The car look like this inside. So how to put it? You just image that for the very little robot. There are a lot of sensors, cameras, and the Lidar, and how to build up the inside a car. So next. You can see that there are our computers inside, and different ways. On the top, you will need a volatile 3D LiDARs for the high end to take the 3D map, build up the 3D mapping along the street. And on the corner side, they will need a 2D LiDAR. Is another brand called SICK. Okay, sorry, John. It's another brand, SICK. Yeah, Volatile, of course, on the top. Okay, and you will need the monitoring and the camera, and there's another thing is about the brightness. There's another story. So when the car is running the outside, you will need the high brightness, the display. Okay, next. So this is the computer we made. You will see it is totally different from what you ever see in the market. Even you visit the COMPUTEX 3 days, 4 days, you will not find such kind of computer inside the COMPUTEX. So this is the products, and we especially customized for our customer, depend on different requirement and the need. So,
thanks for Benjamin share the.
Sorry, one thing I forgot one thing. So today, actually, my personally I like Steve Jobs, but
Steve Jobs.
Today I will not take up the book for you, but I bring something to show. It's our latest products.
Okay, Benjamin bring the newest product I want to show to us. Very rugged and compact, small size.
Yeah, it's interesting. It's slim and tiny, and IP65. Of course, inside the Core i7 CPU board and fanless design.
Yeah,
I love it.
Okay, according to the time, and I think many of the audience might want to get more the information. I think I said it one more time. Tomorrow afternoon, PM 2 o'clock to 5 o'clock, in the Humpo House, 5th floor, we have a room and the room B. We will continue the speakers, their speech. So from the different speaker point of view, we all understand the communication between the different devices, different unmanned systems are critical important, including how to integrate with the subsystems, how to integration with the facilities, play the key role about Industrial 4.0. Among all of those sensors, among all of those cutting-edge solutions, the most of the important technology is in the beginning I mentioned about is the LiDAR. Velodyne is the first company to invent the LiDAR and also provide the cutting-edge solution for worldwide all of the autonomous vehicle makers. However, people like me is always think about why this LiDAR is so expensive. So I would like to have the John to share the technology roadmap, what they can help all of the most developer to do kind of the new device, can enjoy the new cutting edge technology, but with the reasonable cost structure. And I think due to the 2 minutes west from the organization, I think you have 5 minutes. Thank you. John.
Thank you very much, Martin. That's a very surprising question. I don't know if I'm prepared for it. But
So you show the price on the on the screen. Everybody knows how expensive about yours.
there's actually two approaches to your question. One is the technology side, and the other is the market side. And there's a lot happening on both sides that makes LiDAR much more affordable. So this is the technology side, the Velodyne side. When we first commercialized LiDAR in 2007, it was a very large sensor, almost 30 pounds, or 15 kilograms. And the cost about $85,000. A great sensor, but a very expensive, high precision tool. Since that time, we've only made maybe 3,000 sensors total in our history, so it's still a very low volume product. But since that time, we've developed 2 new generations of sensors that have brought the cost and the weight down significantly. The latest generation of sensors, the VLP-16, which is only 1/10 the price of the original sensor. And it's also considerably smaller, maybe 1/20th the weight. And this is still in very low volume. When we move this to automotive level volumes, we expect to be able to create our next generation sensor, the VLP-32, at less than $500 in automotive volumes. And the VLP-32 will be a much more powerful tool, it'll be a much smaller, and it'll be a considerably less expensive tool.
So excuse me, John, when will be you launch the new VLP-32? The end of next year or this year?
No, actually, we've already launched the VLP-32, and our initial automotive customers are already designing it into future platforms.
Okay, thank you.
But that's the technology side. Don't worry about us, we have it handled. Essentially, the LiDAR is just a bag of electronics filled with lasers, detectors, optics, semiconductors. All of that stuff comes down in price significantly with volume. But the other side of the equation is the market. So maybe the next slide. There are so many companies out there that are just growing daily that are going to be using LiDAR in new business cases, not your typical consumer vehicle. Companies like Baidu are thinking about ride sharing, Cruise and Lyft in the United States. You probably know of Uber as well. All of these companies are starting ride-sharing businesses, and the economics of that are very different. You know, currently a personal car is used only less than 5% of the time, whereas a ride-share taxi, like something produced by Lyft, will be used considerably more, 80% of the time, 90% of the time. So the cost of the sensors becomes significantly less critical. In fact, in the case of Lyft, the cost of the driver itself is about 80% of their total costs. So a sensor for $500 is a drop in the bucket. Other companies have other business models. The last mile people, like Easy Mile, which Joel is working on, Navya. Again, those are vehicles that cost over $150,000 currently. So they're very expensive vehicles, but because they replace a significant amount of labor, people can afford, or municipalities can afford them. So that's what's going on. And something like my friend here, when he starts delivering pizza to my house or delivering medicines in a hospital, how much is it worth to replace the person who's doing this? So the economics of the market has shifted dramatically in the last year, and making LiDAR much more acceptable technology for all of these systems.
Very precisely, you catch the last second. Okay, I think today is we almost introduced about our partners' technology background, and also give all of us the new idea and the trend about how to make use of the unmanned technology, how this technology will shape our life, from daily life, transportation, factory automation, or to the battlefield. So before the endings, I would like to mention again tomorrow afternoon, 2 o'clock to 5 o'clock in Humble House. Just walking from here 5 minutes, you can have the more further discussion with all of the guests and our VIPs. So thank you, everyone. Thank you. So could we have the group photo together?
Thank you. Yeah, sure. Gentlemen, would you please all stand up? Let's take a group photo together. And out of the audience, would you please give a round of applause to our speakers? And thank you, moderator, Mr. Martin Ting.